Hello students, in today's class we are going to learn about question number 11 of your EOT. Okay, let's have a look on the question. Apply the law of conservation of mechanical energy. So what is law of mechanical energy? We should know that total energy is the sum of kinetic energy plus potential energy, and if we have any additional energy, let's say spring energy is there, so that should be a sum. So total energy should be equals to kinetic energy plus potential energy plus if you have a spring energy, then I can say E other. Okay, that is the additional energy. For an isolated system, no external force with no dissipated force involved to calculate different quantities. Okay, now let's have a look, and we know, okay, in terms of spring, if we are going to use it, I will explain you few things. A slingshot that launch a stone horizontally, this is the keyword, horizontally, consists of two. This is another keyword because there are the two springs instead of one. Light identical springs. Okay, whenever you have word called spring, you should have two things with you. One is F is equals to negative kx, and work done equals to energy, which is equals to half time kx square. Okay, with a spring constant, okay, k is given, k is equals to 30 newton per meter, and spring, how many, number n is equals to 2 number of springs, and a light cup. Okay, this is your light cup, you can say massless. Okay, light cup holds a 1 kg stone. Okay, mass is given 1 kg. Each spring has an equilibrium length of 5 meter. What does it mean? When it is in normal state, equilibrium, or you can say normal state, the value is 550 centimeter, so you can say 0.5 meter. Okay, when the spring are in equilibrium, they line up vertically. Suppose that the cup containing the mass is pulled. Okay, we need to apply a force. After force, the distance d is your, or x equals to 70 centimeters, 0.7 meter, to the left of the vertical and then released. Okay guys, there are the two cases what I need to discuss with you. You need to understand. Let's say there is a case, you just need to understand. Let's say there is a spring, okay, that is attached, there is a spring that is attached. Clear? Sure. Okay, that is attached with a cup like this. Clear? Right now, what is the length here? 0 0.5, 0 0.5. This is your equilibrium situation. Equilibrium situation. Clear? Okay, now what he said, this is the case one. Now what he said, we are stretching it. Okay, now take this and stretch it to 0 0.7. Here right now we don't know what is the distance, so now stretch it to 0 0.7 meter. So what does it mean? The spring is also stretched, yes or no? So now there is a new distance. You understand? Clear? Okay, so what we need to understand, we need to find this new distance, and there is the distance is given 0 0.5 here. Clear? So we need to find this x new distance before and after. If you are understand this thing, the question will be easy for you. Before, the distance of spring is 550 centimeter. After x we need to find out. Clear? Okay, let's take a, this is your spring, this is your distance, and this is your 0 0.5, this is your 0 0.7, and we are looking for x. So x is equals to root of, use Pythagoras theorem, 0 0.5 square plus 0 0.7 square. So what is the value of x? Okay, solve it. 0.86 meter. Now my question is, what is the change in x? How much it stretch? before we understand, okay, in the case one, we understand this is 0.5. Now this is the x. So now you understand delta x equals to x minus 0.5, because then only I can tell you what is the stretch in the spring. So stretch in the spring is 0.86 minus 0.5, which is equals to 0.36. Is it clear? Yes or no? Okay, so now solve it. Easy thing. So we need to find the u is equals to half k x square. Half, what is the value of k? K is 30. Multiply 30 multiply 0.36 square. Solve this. So what is the value? 1.94 joule. But is this the right answer? No. I told you how many springs we have. How many? Just tell me. Springs. We have 2 springs. Yes or no? So multiply total work done is equals to, or total energy is equals to 2 times of u. So 2 times of 1.94 joule, which is equals to 3.89 joule. Clear? Understand? Okay, now I'm going to add a page here to solve the second part. Add a page. Okay, now what we have, make it big so that it's easy to understand. Part B. Okay, what is the part B? The speed of the stone at x equals 0. What is the meaning of x equals 0? Okay, I will explain this. Now we understand this is the spring. This is also the spring. And this is distance x. Yes or no? As per the given diagram. Okay, let's say this x is equals to 0. Then what will happen? Now just try to understand. This spring moves this side, the spring moves this side. And we are here. This is called mean position. Yes or no? Clear? So in terms of mean position, we know height is equals to 0 and velocity is the maximum. So can I say total energy is equals to kinetic energy plus potential energy. Potential energy becomes 0 at the mean position, and so the value becomes half mv square. Total energy, I solve it. 3.89 is equals to half. What is the mass? Mass is 1 multiply v square. So solve the value. V square is equals to 2 times of 3.89. Okay, so v is equals to root of 2 multiply 3.89. Solve this, you will get 2.79 meter per second. Clear, guys? Fine. Okay, now next question. Okay, now question number 2. 6.52. Suppose the stone in problem 6.51 is instead launched vertically and the mass is a lot smaller. M is equals to this much. Take the zero of the gravitational potential energy to be at equilibrium position. Okay, there are few points what we need to understand. First thing, if I'm considering the question here, let's say question A, determine the total mechanical energy. Okay, first of all, what is the formula of total mechanical energy? I told you kinetic energy plus potential energy plus other. E other. Yes or no? Okay. Now what we have? We have the spring here. So solve one by one. Kinetic energy. What is the value of kinetic energy? 0. Why? Because it is maximum stretched. Yes or no? Maximum stretched means this is the extreme position. So velocity will becomes 0. Okay, what is the potential energy here? mgh. So what is m? 0.1. Okay, g 9.81. Okay, where it is going? Down. It is going down. So down means negative 0.7 because it is given as 0.7 meter. Clear? Okay, third thing, we already solved spring energy. So what is the value? Spring energy is spring energy is what we have, 3.89. 3.89. Okay, solve total energy. So total energy is kinetic energy plus potential energy plus spring energy. Solve this. So we have the value after solving this, 3.21 joule. And as compared to previous question, in the previous we have only, in the previous we have only spring energy, spring. Okay, here we have spring plus potential energy. Yes or no? Fine. Okay, now part B, on which you need to focus. Part B is how fast, means we are looking for velocity. Is the stone moving at it passes the equilibrium point? Okay, there is something given, 0 of potential energy at equilibrium point. Okay, so at equilibrium point the total energy is equals to kinetic energy plus potential energy. Yes or no? And potential energy is 0, given in the question, given in the question. Even if it is not given, even we are not giving anything in the question, then only height is also 0, mgh is also equals to 0. So total energy 3.21, which is equals to half mv square. So v is equals to root of 2 multiply 3.21 divided by mass is your 0.1. So the value is 8.01 meter per second. Clear guys? Understand? So whenever it is in horizontal situation, you need to focus, and whenever it is in vertical situation, you need to think about potential energy. That is your additional factor. Fine? Okay guys, I hope that you understand this logic, this question, and how to solve it. Clear guys? So till question number 11 everything is cleared, and I already covered all the writing part from question number 16 to question number 20. That is already available in my playlist. So guys, take care, bye, and keep on practicing.